Welcome to another video tutorial, and this time we're going to be taking a look at how to build Tetris with HTML5 and JavaScript. Now this is actually a tutorial that I've posted about for a long time. I've been saying I was going to do it, and I do apologize that it's taken me so long to finally get around to it. Just had a lot of stuff come up, been really busy. Now creating Tetris is kind of a rite of passage for any game developer, especially if you're new to it. Tetris is just one of those classic games that everybody knows and everyone knows how to play it. It's a lot of fun and it gives you a really solid foundation into game coding and logic. Alright, now I'm going to go ahead and show you what you're going to end up with at the end of this tutorial. You should have something like this. Now obviously this is fairly basic. We've just got the grid, but we've got the Tetris pieces falling down and they are randomly generated, and you control them with the arrow keys on the keyboard. But since this is HTML5 and JavaScript, we're also going to go ahead and make sure that this will run on a mobile device, and that's obviously one of the advantages of HTML5 and JavaScript game development, is that your games will run natively in the browser on your mobile phone or tablet. So that's enough of this. We're going to go ahead and take a look at how to get started here. The first thing we're going to take a look at is just the directory structure, how to set this up. And I'll just have you set it up the same way, I set it up initially. So you can see here I've got a CSS folder. That's where some styling goes. There's a little bit of styling, but not too much. There's a JavaScript folder, and that's where any extra JavaScript files are going to go. Most of the JavaScript is going to be in our main index file. You can see here I've got this bulk image loader.js. That's actually from a previous tutorial I wrote in preparation for this one, and you can grab that off my website. Just go to the main page, find the tutorial about loading images with JavaScript here. Now in addition to that, we've also got these 3 images, and you can download those from my website as well. I might just put together a little starter pack that will have this directory set up with all this stuff in it already, so you can just kind of start from here. But this is going to be the background image for the board. These are going to be our Tetris blocks, and feel free to make your own if you want to. Just do be aware that this has 8 blocks. These are 32 by 32 pixels, and if yours are not the same size, the math might not come out right. And then we have a little game over screen. The next thing we're going to want to do is go ahead and create a JavaScript file where we're going to define the individual Tetris pieces. Now I'm going to use Notepad++. Obviously you can use whatever text editor you prefer. And since functions are just objects, we're going to make our pieces functions. Let me set my language up here to JavaScript. So we'll say function lPiece. I'm going to stop right here because I want to talk about how we're going to be defining these pieces. Because Tetris is actually based around the idea of 2-dimensional arrays. So an array of arrays. That's how the game board will be represented later on, and it's how our pieces are going to be represented right here. I'm going to go ahead and open up a new file to kind of demonstrate this and maybe just illustrate the point a little bit better. So here we open an array. Now we have another array inside of that. And anywhere where there's actual data, or like a Tetris block, is going to be a 1, and empty space is going to be a 0. So if we wanted to make an L piece, all we have to do is make 1s in the shape of an L. So the first parameter here is going to be a 1, then we're going to do a 0. And it helps to think of these in terms of rows and columns, so that's row 1 of an L. Row 2 would look something like this. I'm going to push this over so we can see that clearly. And the last row of the L is going to look like that. So now you can see that the 1s where the actual data is forms an L, and the 2 zeros are empty space. So that's what we're going to do here. We're going to hold each rotation of the piece in an array of arrays. So I'll start and I'll call it state 1. We'll open that array, and just like we did in that other file, make 1, 0, Next row is also 1, 0. Then we've got 2 1s at the bottom. I'm going to close off both arrays there. Come down here, we'll make a state 2. And now what you have to think of is we're rotating the piece. So what happens if you rotate this array of arrays, the shape, to the right? Well, if you do that, your zeros are going to end up here. Oh, forgot to open my initial array there. Then the bottom row is just going to be all 1s. So you can see now that that L has been rotated to the right. So we're going to go to state 3. And if we rotate that L again, we're going to get something like this. And we've got one more state to take care of here. This time, all the 1s are on top. And there's your 4 states, 1 state for each rotation of that L piece. And just for easier reference, I'm going to store all of those in another array just called states. So I'll just push them on there one at a time. State 1, 2, 3, and 4. Then I'm also going to want to hold a reference to the state the piece is currently in. So I'll make a variable here called cur_state. I'm just going to set it to 0. So that's going to be state 1. Then we need just a few other properties here. We'll give each piece a color, which will default to 0. And we'll also give them a grid X and a grid Y. Oh, I'm going to go ahead and save this. We'll save it as pieces.js, and I'm saving that in the JS folder. So the grid X and grid Y is just going to keep track of the piece position within the game board. And I'm starting it at -y because I want the piece to initially not be visible on the board. It'll, how Tetris does, it'll just slowly drop into the scene. And the X position at 4 is just going to kind of center this piece, along the X-axis. So the next piece is a reverse L. So I'm just going to go ahead and copy and paste this because it's going to be pretty similar. Just need to swap some of these values here. That's going to become a 1. So we've got a backwards L there. And if we rotate that to the right, put something like this. Rotate it again. And the last one. So that's our L piece and reverse L piece. Next we'll do the block piece. And this one's actually pretty simple because it's just a block. It doesn't even rotate, so it's only going to have 1 state. And it's just going to be all 1s. He's going to need, all these properties also, so we'll go ahead and copy and paste those in. But since the block is only 2 pieces high, we'll set it to -2 instead of -3. Next up is going to be the line piece. I'm just going to copy and paste this. Save myself some typing. And the line piece is also fairly simple. Oops, it's just going to be 4 1s here. But then this does need an additional state because you can lay it flat. move this one over since he's only 1 unit large, or 1 unit wide. But since it's 4 units tall, we're going to move it to -4. Next we'll have the T piece. So you can see now the ones form a T shape here. And if you rotate it to the right, you're just going to end up with a sideways T. Copy and paste these. This will be state 3, this one will be state 4. And we need to switch these values here because now the T is upside down. And we'll swap these as well. I'm going to grab these properties here. We'll add our other 2 states because this one has 4 states. State 4. And we'll just adjust these X and Y values. So the next piece is going to be the Z piece. We just want to draw a Z with our ones. That's what we've done here. And if you rotate that, you get something like this. So you'll notice the Z only has 2 states because what happens if you rotate it again from here is you just end up again with this first shape. So we'll set his cur state to 0. Just going to copy the grid X and Y from up here. Actually, I'll copy the color also. So we've got one more piece to do, and that's going to be the reverse Z. So we'll just copy and paste this. Makes it nice and easy for us. All you got to do is draw a backwards Z. So now we've got all of the pieces defined, and I want to just add one more function in here, and I'm going to call it getRandomPiece. So obviously this function is going to be the one we call in the game code whenever we want a new piece for the game. So first we just need to grab a random number. So because we've got 7 different pieces, we just need a random integer from 0 to 6. So that's 7 total. And we'll just switch on that result, see what we got. So now if we get a 0, we'll just say piece equals new L piece. 1, we'll do a block piece. I'm not going to put the reverse L right next to the L piece. So a Z piece. T piece. Right now we'll do the reverse. New reverse L piece. Do the reverse Z. And finally we'll do the line piece. Okay. Next we're going to set the color of this piece to a random color. So we'll do math.floor, math.random times 8. And then we'll just return piece. Now we're doing times 8 because if you'll remember in that block image there were 8 different colors. So we're going to get a value from 0 to 7 here, and we'll just use that to determine which color of block we're going to use. So now we've got all of our pieces defined and we're ready to kind of move on to the main index.html file. And I'm just going to dump most of the game logic into that file. So I'm just going to come up here, make a new file. I don't need this one anymore. I'll set it to HTML. And here we're just going to make a very basic HTML file. We'll start with the doc type declaration. Open our HTML tag, close it, put a little header in here. And I'm going to give this a title. I'll just call it Tetris HTML5. That'll be it for the header. We'll come down and do the body. And in here we're just going to put a couple of divs. The first one I'll call game board. And inside of this one we want to make a canvas tag. I'll call that game canvas. We also want to give this a width and a height. So our Tetris board is going to be 320 pixels wide and 640 pixels high. I just chose that width and height because 32 divides nicely into both of those, and since our Tetris blocks are 32 by 32 pixels, they'll fit nicely in here. So we'll come down here, we'll make another div, call this one score, and we'll put a paragraph tag in here along with a span. So now whenever the user gets a line, we can go ahead and update the text here and let them know how many they have. Underneath that div, we're going to go ahead and put a script tag. This will be JavaScript. And in here we're going to load that pieces.js. We'll do one more script tag here. And for that we want the bulk image loader.js file. And I lied, there's actually going to be one more script tag because obviously we need somewhere to put the game logic. So this will be JavaScript. I'm going to go ahead and save this. Save it up here, call it index. And actually, I'm going to come back up here in the header. I'm just going to link to a style sheet. CSS. To style.css. And again, this is something I'd done before, so I'm just going to pull that file up so you can take a look at it now. And if you want to, you can pause the video here and copy all this down. Or like I said earlier, there's a starter pack on the website for this tutorial, and that'll have it in there as well. Now let's see what this looks like. Nothing too special just yet, but we've got the space here for our game board and also the text for the lines, where we'll tell the user how many lines they've actually gotten so far. So we'll just come back to our HTML file here. All right, we're going to begin by just declaring quite a few variables here, but this will be pretty much everything we need for the whole game, so just kind of bear with me here. We're going to start with the number of rows. It's going to be 20. Columns is going to be 10. And the size is going to be 32, because that's how big the blocks in our image were. So we've got quite a few more here. We're just going to do a canvas, and this will be context. That's going to be a reference to the 2D context of the canvas. Now we've got a few images. The block image, the background image, and the game over image. Now we'll do some variables here that relate to the core functionality of the game. So do curve piece. Obviously that's going to hold a reference to the current game piece that's moving around. Game data, that's going to be a two-dimensional array that represents the game board. Oops. Image loader is going to be that bulk image loader. We're going to use that. And we need to keep track of some times here, so we'll do previous time and cur time. Then we'll do a boolean here, is game over. Line span and cur lines. So the line span is going to be a reference to that span object up here. And cur lines will just be the number of lines that the user currently has. So we'll do window on load equals on ready. And this on ready is a function that we're just about to write here. So just skip down a couple lines, do function on ready. Now the first thing we're going to do in here is go ahead and instantiate the bulk image loader. And then we need to load in our game assets. So we'll do image loader dot add image. We'll say blocks.png. And you can see here we first pass in the path to the image, and then the second parameter is just kind of a more convenient name to refer to the image by if we want to later on. And that's just kind of how this bulk image loader works. And again, that's something that you can download from a previous tutorial I'd written. So we need to add our next image. It's going to be the background. So bg.png. Let's call that bg. Got one more. And then when all the images are loaded, we want to give it a callback. So we'll say onReady callback equals on images loaded. And then we'll go ahead and actually load the images. So image loader dot load images. Now down here we're just going to initialize a couple of these other variables. The canvas, we document get element by ID, game canvas, get context, I'll set up the previous and current time. We'll set them both to 0 at first. And then because we want to actually handle input, say document dot on key down equals get input. So there's a couple of functions in here that we haven't actually written yet, on images loaded being one and get input being another one. We're going to just go ahead and do on images loaded next. So function on images loaded does take in an event. And in here we're just going to grab the images from the image loader and store them in our local reference variables here. So the image loader, we say get image at index. We'll say 0 because the block image, as you can see up here, is the first one we added. This will be 1. And the game over image. It's the last one we need to grab here. That's going to be 2. Now this image loader does have another function where you can get an image by name, and that's kind of where these secondary parameters come in up here. But since we only have 3 images, I'm just grabbing them by index. And now we need to call another function down here called initGame, which we haven't written just yet, but we'll go ahead and take care of that right now. So just come down here, make another function. Now in this function, what we're actually going to do first is create that game data variable. And what that is, it's going to be a 2-dimensional array that holds the current state of each spot on the grid. So we're going to do vars R and C for rows and columns. We'll also set curlines to 0, and is game over is false. And now we're going to check if game data exists. So if game data is equal to undefined, then we need to go ahead and create it. So game data equals new array. And now we need to actually add some data to that. So we're going to do that with a double for loop. R is equal to 0. R is less than rows. R plus plus. We'll say game data sub R equals new array. Because remember, this is a 2-dimensional array, so it's an array of arrays. For C is equal to 0, C is less than columns, C plus plus, and game data sub R dot push a 0. So this is just going to loop through that game data array and set everything to 0, so we're starting with a clean slate. Now we need to come down here, and if the game data does exist, then we just need to go through and 0 everything out. So again, we're going to do a double for loop. R equals 0, R is less than rows, R plus plus. The same thing for C. C is less than columns. C++. And here we just want to do game data sub R sub C equals 0. So now that we've created the board, we'll just come below this else statement, just set up a few other things like the current piece. We'll set that to get random piece. And remember that function is actually in the pieces.js file, which we did include above. We'll say line span dot inner HTML equals cur lines dot toString. So that should be 0 since we set that right up here. Now we need to get the request animation frame function. So I'm just going to do it like this. It's probably kind of a quick hack, but it's good enough for here. So all we're doing is checking for all those browser prefixes here, just to make sure we get that function if it's available. And we'll say window.request animation frame equals our variable up there, request anim frame. And down here we just need to say request animation frame and pass in update, which is a function again that we haven't written yet. Now I'm going to go ahead and start this update function here. We're not going to complete it just yet, so we'll have to come back to it, but I want to get some of this other groundwork laid here. So the first thing we're going to do is set cur time, new date, get time. And then we're going to update our pieces every half second. So we'll say if cur time minus prev time is greater than 500. Then in here is where we'll actually update the game piece. And we also need to update the time. So I'm going to skip over this updating the game piece for now, but we will come back to it. But first, we're going to start drawing our actual board. So we're going to say the context, which is CTX. We're going to clear that rectangle. Remember that 320 by 640 is the size of our game board. Then we're going to call a function called drawBoard, which we'll write next. And then draw piece. And we're going to send in cur piece. Then at the end of update, we just want to check if is game over is equal to false. Then we want to go ahead and we want to keep updating. So we'll say request animation frame update. If the game is over, then all we need to do is draw that game over image to the context. So game over image. And I'll explain these parameters in just a minute. So the draw image function takes in an image to draw, and then these first four values define the points from the source image that you want to draw. We want to draw the entire image. So our background, or the game over image, is 320 by 640, and it fits right over our game board. So we're going to start at 0 on the X, 0 on the Y. We're going to grab 320 pixels wide and 640 pixels high. And the last four are where on the canvas do you want to place this? So again, since it's taking up the whole thing, we're just going to use 0, 0 for the X and Y, 320 for the width, and 640 for the height. And we're going to be using this draw image function in other places as well, so you will definitely see it again. Next, we're going to go ahead and write that draw board function. So function draw board. And in here, the first thing we're going to do is actually use that draw image function again. And this time we're going to pass it the background image. And again, we want the whole thing. So we grab that, and it fits exactly in our game board space. So we'll just pass in the same parameters there. And now we need to go through and actually draw individual cells. So we'll just loop through our rows and columns. Equals 0, R is less than rows, R plus plus. Or C equals 0, C is less than columns, C plus plus. And then we need to check what the value is at this position. If game data sub R sub C is not equal to 0, then that means there's some part of a piece in that position. So we need to draw that. So we're going to say our context, again, draw image. This time we're going to use the block image. And here we're going to say game data sub R sub C. We'll do -1 times size. Now you might be wondering why we're subtracting 1 here. And it might not make a whole lot of sense just yet, but it will later on. But I'm going to go ahead and explain it a little bit here anyway. So the way our game is going to work is when a piece hits the bottom of the board or another piece and it has to stop, then we're going to copy the value of that piece's color onto the game board. So if you remember over here in pieces, we're assigning a random color. It's going to be 0 through 7 for a total of 8. But the problem is when we copy that data into the board, if a piece's color is 0, that's going to represent an empty space. So when we copy the data to the board, we're actually going to be adding 1 to it. And that's why we need to subtract here, so we're grabbing the right color. And we'll take a look at this block image. It might make a little more sense. So remember, a piece that has a color of 0 is going to be this dark blue here on the left. But we can't copy a 0 into the game board, remember, because that's empty space, so we copy a 1. But then when we go to draw that piece, if we say 1 times size, we're going to get this green block when what we actually want is a blue one. So that's why we subtract 1, and then we end up at 0, so then we can draw the blue block. Alright, so the Y is 0 because that image is just flat. And our block size is 32 by 32. I could use size here. So C times size, R times size. So let's make sure we're on the proper row and column in the proper spot on the grid. Say size, size. Actually, I will go ahead and put that over here. So that's going to actually draw the game board. And initially it'll be blank because all the data is going to be 0. But once pieces start landing and we start actually filling in different numbers in our array, then we're going to use that data to figure out which color block to draw. So back up here in Update, took care of draw board. Now we need to take care of draw piece. So right beneath draw board, just make a new function, draw piece. It's going to take in the current piece. And now we need just a few variables here. Say draw x. It's going to equal the piece dot grid x. We'll do a draw y. Piece dot grid y. And we'll also save the current state of that piece. So piece dot current state. So now what we need to do is just loop through that piece in its current state and draw it onto the board. So the way we're going to do that, again, a double for loop here. There's a lot of those in Tetris. So that's going to take care of the rows for us. Now we need the columns. Say length 2. So we want the current state, and remember we saved that in this state variable up here. So p.states sub state and the current row there, so the sub r. And remember that's each row in the piece is just another array, so we're going to get the length of that, and that's going to give us the columns. Now we just need to check if the current spot on the piece is a 1. So if p.states sub state sub row sub column is equal to 1 and the draw y is greater than or equal to 0, then we're going to go ahead and draw the image. So ctx draw image, block image, the color of the piece times size, say 0, that's the y. Then we'll do size, remember that's from the source image, and we want to draw it at draw x times size and draw y times size, and then we want to draw 32 by 32. And we just need to increment draw x by 1. And then once we're done drawing a row of columns, we need to reset the draw x. And update the draw y. Let's switch back over here to pieces.js. If you can imagine, we're looping through this reverse z piece. First we're going to do states in its current state, whatever it is. We'll say it's state 1 for this example. Then the first thing you're doing is looping through this first row, and then you're just coming down here and doing the second row. And that's why when we get to the end of the columns, we need to reset the x position to the left side here. And we also update the y position because we're going to be drawing not at the exact same y position that this one was at, but we need to go down 1 unit. We'll come back over here to index. So we're going to go back to the update function, and we'll start updating this game piece here. Now again, there's going to be a couple of functions used here that we haven't written yet. We'll get to those as soon as we're done here. So the first thing we want to do is use a function called CheckMove. I'm going to say the cur piece dot grid x, cur piece dot grid y plus 1. And we will also send it the current piece current state. So what this CheckMove function will do is going to see if that current piece can actually move down 1. And if it can, then we're going to go ahead and update its grid y. Otherwise, that piece is done dropping and we need to copy its data into our game board. So now we'll use a function called copyData. We'll send it cur piece, and then we'll get a new current piece. So we'll use that getRandomPiece function. Now instead of going with CheckMove right away, I'm going to come down here right above drawBoard, and I'm going to do copyData. Remember that takes in the current piece. And this is actually going to look fairly similar to our draw piece function. So I'm just going to copy and paste that into here. And it's not exactly the same, but it's close enough to where we're going to use a lot of the same stuff. We're actually going to rename these to just X position and Y position because we're not actually drawing anything in this function. So now anywhere in here where I had draw X or draw Y, I'm going to change it to X pose and Y pose. So if the Y position is greater than 0, and in here instead of drawing the image, I'm just going to copy the data to the game board. So I'll say game data sub Y position because we're doing row then column, then X position. We'll say it's the piece.color plus 1. And here we're just going to update the X pose. And we need to reset it down here. We're also going to increment the Y position. And remember up here, why are we doing a +1? Because if the color is 0, then that means it's empty, so we can't have a 0 color. So we need to go ahead and just add 1 to be safe. It doesn't matter anyway because we're subtracting 1 when we actually draw the board down here. So it evens out. And there's probably a better way to do that. But again, this was just a weekend project. So underneath this, I'm going to do a function called checkLines. And that's just going to check for any completed lines on the board. And we will also check if the piece grid Y, its Y position on the grid, is less than 0, then the game is over because obviously that piece stacked too high. So we'll say is game over equals true. So next we're going to go ahead and write this checkLines function just so we can kind of be done with this area of the logic. So we'll say function checkLines. Say line found be false, full row equals true. We'll do our rows equals rows minus 1, columns equals columns minus 1. Now instead of a double for loop, I'm just going to do a double while loop, and I'm going to loop backwards through the rows and columns. That just makes it easier. So what we want to do in here is just check if game data sub R sub C is equal to 0. That means it's an empty space. So clearly the row is not full. So then we'll switch full row to false. And we'll just say C equals -1. Because at that point we already know the row is false. There's no sense to keep going through it. So we need to make C less than 0. Otherwise, we'll just C minus minus and keep looping through that row. So once we've gone through all the columns in that row, we can check if full row is equal to true. And we need to zero out that row. So we'll write a different function called zero row. We'll pass it the row number. Increment R. Say line found equals true. And cur lines plus plus. Then we'll come down here and we'll say full row equals true. C equals columns minus 1. Because if we did actual columns, that'd obviously be out of bounds. Actually, I've got an array thing here. I need a bracket. There we go. And then we will decrement R as we keep going through the different rows. And you'll notice here I'm setting this to true because we always assume that the row is full, and then once we discover a blank space, then we say, okay, the row is not full, and then we can just break out of this loop here and continue on. So we actually introduced another function here, zero row. We'll go ahead and write that down here. Zero row, and it takes in the row that it wants to zero out. If our R equals row, c will equal 0. So this function might be a little bit misnamed, or it doesn't necessarily zero out a given row. In Tetris, if you get a line, then all the rows above it come down. So what it's actually doing is copying the data from the row above the target row into the target row. So we loop through all the rows all the way down to the first one, and we're also going to loop through the columns. And if r is greater than 0, then we need to go ahead and copy the data from the row above it. So game data sub current row sub current column equals game data sub r minus 1 sub column. And again, that's just going to copy the row above us, copy that data into the current row. Say game data sub r sub c equals 0. And we increment our column. So if there's valid data above us, we copy it in. If not, we just make it 0. So if you're wondering why we're going backwards through the rows here, it's because if you're 4 lines down on Tetris and you get a line, all you need to worry about is the lines above you coming down. The ones below you don't change. So that's why we're just checking up on the rows. We're going backwards through them and copying the data down. So now if you remember back in update, we had a CheckMove function. It's time to go ahead and write that. And I'm just going to come all the way down here, probably at the very bottom actually. That's where I'll write it. So function CheckMove. It takes in an X position, a Y position, and a new state. Do some initial variable setup here. So this function might get a little complicated, but it starts off pretty much the same as all the others. We're just going to start with that familiar double for loop, where we need to loop through the rows and columns. Let's go ahead and do the columns. So now what we basically just want to do here is do a series of validation checks. You can see when we come in that we're assuming the result is true, meaning this is a valid move, we're going to allow it. But we need to make sure. So the way we do that is we need to check if the new X position is less than 0 or it's greater than the number of columns, greater than or equal to actually. Then result is false. And we can reset, length 2, r equals length. So these two lines just make sure we get out of here. We don't need to loop any further because we've already found the move is an invalid move. The X is either less than 0, meaning it's to the left side of the board, it's not even on the game board, or it's too far to the right and it's going off on the right side, so we can't do that either. But if it passes this validation test, then we've got another one to check for. So if game data, this is row, so new Y. I'm just doing the undefined as a kind of safety check. This one's kind of bigger. Oops, it's cur piece. Dot states, sub new state, sub row, sub column is not equal to 0. And again, result is going to be false. C we can set to length 2. R will set to length 1 because we don't need to loop anymore. So what is this check doing? Well, let's take a look. First, we're basically just checking if the position on the board where this piece is trying to go is not equal to 0, then that means it's already occupied by another piece, so we can't move there. And then we also need to check the data for the row and column of the current piece to make sure it's not 0. Because if it is 0, then even if there is data in that spot, it's okay to go there because it's an empty space from the piece. But if the piece has actual data there, so it's a 1, and then the game data is not 0, then that means there's two pieces hitting each other, so we can't move to that position. So what we want to do is just say new x plus equals 1. And once we're done with that, we say new x equals x position, new y plus equals 1, because now we want to check the next row of that piece. And last, we just check if new y is greater than rows then that's also invalid because you can't have your piece fall below the game board, right? It stops at the very bottom. And finally, at the end here, we can just return that result. So let's walk through this one more time because there's actually a lot here. So again, we're just checking the position that we want to move the piece to. It's not the piece's current position, it's the position that you want to move it to. So we come in here, we got to loop through the rows and columns of our piece. We check if it's out of bounds of the board. Is it too far to the left or too far to the right? Then that's not a valid move, so we set result to false. Then we check if it's actually hitting another piece. And if it is, again, we can't occupy that space because there's already another piece there, so the result is false again here. And then last, we come down here and check if the Y position of the piece is valid, because if it's greater than the number of rows, that means the piece is below our game board, and that's not allowed. So again, we set that result to false, and we return it. So now, if you come back up to update, you can see the piece is falling down, and so we're adding 1 to the Y position, and again, that's the position we want to check. Is this valid? If it comes back true, then yeah, go ahead and do it. Otherwise, that means the piece has actually hit something, either another piece or it's at the bottom of the board. So we just copy its data into the game board and we get a new piece. Now, if you'll remember back at the top here, we did document.onKeyDown equals get input. I'm just going to go ahead and write a function here for that real quick. For now, I just want to save this. I'm going to test it and see what it looks like. Let's go ahead and do that. We'll come here. We'll open it up. Oh, looks like something's not working quite right here. Let's take a look, see what happened. Okay, up here, I just forgot to close this script tag. So let's give it another shot now. And there we go. So now you can see we got the pieces falling. I can't control them just yet. We'll see what happens when it hits. Hopefully we get another piece. Okay, yeah, so there we got another one coming down. Okay, so far so good. We just need to actually add some input handling here. So we'll come down here to our get input function. And the first thing we want to do is just make sure we have a valid event. And I'm going to go ahead and do prevent default. Because if you don't do that and you use up and down arrows, then it kind of scrolls the screen. So now we really only need to handle input if is game over is not equal to true. Because if the game's over, we don't need to handle any input. So now we're going to go ahead and switch on the event's key code, see which was pressed. So 37 is actually the key for the left arrow. So here, if you press left, that means you want to move the piece to the left, so we need to check and make sure that's a valid move. Say CheckMove. The current piece, grid X, -1 because we're moving it to the left. Current piece is Y is going to be the same, so just say grid Y. And we'll get its current state. And if that checks out, then we can go ahead and move that piece to the left. Now we'll do the same thing for the right. And 39 is the code for the right arrow. So again, we're going to check move, curve piece, grid X, this time +1. And the current state. So if that's okay, and we will just move the piece to the right. Next, we're going to check if the up arrow is pressed. And if it was, that means we're going to rotate the piece. So what we actually want to do is get what the new state will be after it's rotated. Current state -1. We need to make sure that's valid, so if new state is less than 0, new state equals curve piece dot states dot length -1. So now we need to check that move, make sure it's valid. So we're not moving on the X or Y, so we'll just pass in the current grid X and grid Y. But we're going to check the new state. So if that's okay, say the current piece, current state equals new state. And the last key we need to check for here is the down arrow. That's code 40. So if you press down, you just want to move the piece down, so we're going to check grid Y +1. Check its current state. And if it's okay, we'll go ahead and move it down. So if game over is true, we're just going to come down here and call init game, and that'll kind of reset everything for us. So now the game should actually be ready to play. Let's give it a shot and see. Okay, I can rotate the piece with the up arrow. I can move it left and right. If I hold down, it'll slam the piece into place. Here we go. So yeah, now the basic gameplay is working. Let's see if we can actually get a line here. And we did. Although we didn't update our line count on the screen, so we should probably do that. So for that, we need to go to our check lines function. I'm going to jump to it here. And at the end of this double while loop, we just need to see if line found then we need to update the current line count. Okay, now we'll just check that and make sure it worked. Over here, I'll just try to get a line as quick as I can. You can see the pieces rotate. And here we go. This should give us a line. Yep, we got our line count updated here. And now we'll just check the game over, see if we can wreck this as quick as possible here. Just give me a few more line pieces. That'd do it. So the next one that falls should be game over, and there it is. And if I hit something, the game resets. So that's that. You now have a fully functioning game of Tetris with HTML5 and JavaScript. There's just one other thing we need to do here, and that's make this work on mobile devices. Right now, we're using the arrow keys for input. That's not really going to work. And one other thing, I'll show you a quick little quirk right now. You'll notice over here on the left, you can rotate all you want, but if you take it here on the right, then you can't unless you're far enough away to have room to rotate. And that makes sense, but what would probably make more sense is if you're over on the right and you don't have room to rotate, you should be moving that piece over automatically and rotating it. I'm not going to go through that here, I'll leave that up to you. But I'll just give you a hint. What you're probably going to want to do is just use that CheckMove function and push that piece over until it can rotate. And if it's a valid move, then let them do it. If not, don't. But let's get started on making this work on mobile devices. So making this work on mobile devices isn't actually all that bad. We just need to come back up to the top here. And we need to add just 3 more variables. Do the touch X, touch Y, and a touch ID. Now we need to add a couple of listeners to the document. So we'll say document.body.addEventListener, touch start. And I'm just going to make these inline functions here. So the first thing we want to do is just prevent the default behavior. Now we're going to say touch X equals e.touches sub 0.pageX. We'll set the Y also. And we need to get that touch ID because multiple touches can happen. So identifier is what we're looking for here. Next, we're going to look for a touch move function. So we'll say body.addEventListener touch move. And again, we're going to prevent the default behavior. And we're going to calculate the difference on the Y. And in this case, if you're swiping down, that means you probably want to move the piece down. So I'm just going to use an arbitrary value of 60 here. So if the touch has moved more than 60 pixels, then we want to go ahead and move the piece. So we'll check move curPiece dot grid X curPiece dot grid Y plus 1 and the current piece current state. And if that's okay, just like before, curvePiece.gridY++. And 60 might seem like a lot, but touches are not nearly as accurate as the mouse, so you don't want people accidentally slamming the piece down. So I kind of just played around with it, and 60 felt kind of natural to me, so you can change that if you want. But we've got one other function to take care of here. Oops, we need to do document.body.add event listener. That's the touch end. So just as before, we're going to prevent default behavior. We're going to do a couple of variables here, the touch end x, touch end y. And we need to actually grab the current touch. So touch equals e dot changed touches dot item sub 0. I'm going to wrap this in a try just in case it fails. So touch end x equals touch dot page x, touch end y equals touch dot page y. Catch that error. Go ahead and show an alert if that occurs, and we'll return. So that should really only happen if for some reason we don't get any changed touches in here. The next thing we're going to do is just take the difference between the touches end x and its starting x, and also the end y and starting y. So we'll say diff x equals math. We'll do absolute value here. We'll use touch end x minus touch x, and we'll do the difference on the y. Touch end y minus touch y. So what we're basically going to just do here is check if the screen was, did they touch and swipe, or did they just kind of tap the screen? And if they tapped the screen, then we're going to rotate the piece. So I'm going to check if the difference of x is less than 10 and the difference of y is less than 10. Then they probably just tapped the screen. They didn't really move their finger much. So if that happens, then we're going to do this new state equals curvePiece.curveState minus 1. And this should look familiar because we've already done this with the arrow keys. So if new state is less than 0, then new state equals curvePiece.states.length minus 1. And then just like before, we need to check to make sure that's a valid move. curvePiece.gridY and new state. And if it's okay, then curvePiece.curveState equals new state. Now, I know this isn't really maybe the official way to do it. This is just kind of something I came up with on the fly for checking if it was a touch or a swipe. There's definitely better ways you can do this. So if it's not just a tap and the difference on the x is greater than the difference on the y, that means they were swiping left or right. So we need to see if touch end x is less than touch x. That means they swiped to the left. And we need to check if we can move the piece to the left. curvePiece.gridX minus 1. curveState. So if we can, then okay, gridX minus minus. Otherwise, they were swiping to the right, so we need to move the piece to the right. And I'm actually just going to copy and paste this instead of typing it all out again. So now we're actually going to jump back up to the header of the HTML way up here. We're just going to add a couple of things for Apple. So Apple mobile web app capable. Content equals yes. And we'll do another one here. Apple mobile web app status bar style. Content equals black translucent. And probably one more, this may be the more important one, is the viewport. We're going to make sure that users can't scale it, so we'll say scalable equals no. Set initial scale 0.5, and again, that was just something I played around with, and I tested it on my iPhone 4S and also a Nexus phone from Google, and it looked good on both of those. We'll say maximum scale equals 1. User scalable equals 0. And I don't even really know too much about these things. I mainly found them just by Googling when I was looking up how to get this to run on mobile devices. But this works for me, so it should work for you also. And give it a shot. That brings us to the end of this tutorial. I hope you had a good time, and I hope everything works out for you. If not, check the website. All this code is on there. You can download it, compare it to your own, maybe look for any differences. Thank you.